Okay, so this is exam 1 for physics 202, spring 2012, multiple choice. Which of these statements is true about charging by induction? It can only occur with protons. That's not true. Causes a bigger charge than charge by conduction. That's not true necessarily. It cannot be done to conductors. No, you can do it to conductors. But by induction, by definition, means that you don't have contact between the objects. So the answer is D. Look at this kid. What's her problem? The back of her head is positively charged. That doesn't make any sense. The day is really, really humid. No. She has an excess of negative charges. So on her hair, or actually over her whole body, she has an excess of negative charges. So all over her body. Look, she's negatively charged everywhere, because she just went down a slide or whatever, and that's causing all of her hairs to repel from one another. Although the negative charges are repelling from one another. So the answer is C. A charged particle sits in an electric field as shown here. If the particle moves in the direction of the dashed line to the left, what is the charge of the particle? Positive particles feel a force in the same direction as the electric field. So this one's opposite, so it must be a negative. The following figure shows equal potential lines for a configuration of charges. Which charge has the greater magnitude? Alright, well I know that V is KQ over R. So the potential that's bigger, see the 66 is bigger, so I have the bigger charge here. So that is the positive charge. 4 is A. Following plot has a potential of V versus position X. You release a proton at X equal A. A proton, a positive charge, is the one I'm going to move from high to low potential. So it's going to move from here to the left. Alright, that's to the left, C. It's moving from a less negative value to a more negative value. That is a larger value to a smaller value. It would be like a proton, putting a proton here. That would be X equal A, and it's going to move in that direction towards the negative particle. That is where the potential grows more negative. So the answer is C. What is the equivalent capacitance of this circuit? Alright, well, the equivalent of these two is 2 microfarads. That's 1 over 3 plus 1 over 6. And then we combine it with this one and this one. 2 plus 1 plus 2 is equal to 5 microfarads. So number 6 is B. So what is the potential in an electric field at a point P, which is the center of the square? First we have 3 positive charges and 1 negative charge. That means that our potential is not equal to 0, because they don't cancel out. And then I need to go through and just look at the field due to each one. Let's look at this one. Its field is going to be in that direction. Due to this one, its field is in that direction. Due to this one, its field is in that direction. And then due to this one, in that direction. So the electric field also is not equal to 0. So that is option B for number 7. What is the voltage across the 2 microfarad capacitor? I need to combine these two capacitors. That gives me 2 plus 4, which equals 6. So my new circuit looks like this. I have 2 6 microfarad capacitors in series. They share 12 volts, so they also have 6 volts across each of those. But I want to know the voltage across this one. It's also going to be 6 volts, so that's C. This one's 6 volts because these two are in parallel, so they both get 6 volts. Charge a capacitor with a battery, 10 volts. Then you remove the battery, so the charge remains constant. Then you double the distance between the plates of the capacitor. What is the new voltage across the capacitor? Alright, so Q is equal to C times V. I also know that C is epsilon naught A over D. I am doubling the distance. That decreases my capacitance by a factor of 1/2, which means that if my charge remains constant, my voltage has to increase by a factor of 2. It was 10, now it's going to be 20. That's D. Primary purpose of a capacitor is to store electrical energy. I want to measure the potential difference across a resistor. How do you hook up the device? You hook up voltmeters in parallel with a resistor. Which has a bigger resistance, a hairdryer or a light bulb? The one with the bigger resistance is going to be the lower power one. So that's the light bulb. D, number 12 is D. You can think about this in 2 ways. Mathematically it just works out because V is equal to V squared over R. If R goes up, P T goes down. Alright, or you can just think about it that if my resistance is bigger, then I'm not going to get as many electrons going through that device. Alright, whereas if my resistance is small, then I'm going to get a lot of electrons. Alright, a lot of electrons translates to higher power. Alright, so a lot of electrons passing through will go through a low resistance and give you a high power device. So I'm looking for the bigger resistance. That's going to be the lower power. Fewer electrons going through a bigger resistance, giving us lower power, less light, less heat, whatever. So the circuit was the current through the resistor. I know that I is V over R, just simple plugging in. That's 24 over 2, which is 12 amps. So it's A. Rate for electricity charged by energy is 5 cents per kilowatt hour. Yeah, I think that's low. I think that the rate is more like 15, 16, 17 cents. But this is what I found on the internet. So how much does it cost you to run your 1,000 watt electric heater for 2 hours? So we have $0.05 per kilowatt hour times 1 kilowatt, that's 1,000 watts, times 2 hours, so that's 10 cents. That is D for number 14. And which of these best describes an ammeter? Doesn't measure voltage. It does have a very small resistance. For B, it's not hooked up in parallel, it's hooked up in series. It has a very high power rating. No, it actually has a pretty small power rating. Yeah. Alright. So, what is the electric field in vector notation at that point? First, you had to take the partial derivative of V with respect to X, Y, and Z. So EX is negative del V del X. That's negative 3Z plus 8X squared YZ. I'm taking X equals 0, Y equal 2, and Z equal 1. That comes from this information. And so that gives me negative 3. EY is negative del V del Y, which is negative 4Y plus 4X squared Z. I put in my coordinates for X, Y, and Z, gives me 8. And then finally, is that right? Let me just double check. Yeah, 8. And finally, EZ is negative del V del Z, which is negative 3x plus 4x squared y. X is 0, so that's all equal to 0. So my electric field in vector notation equals negative 3I plus 8J, and that's in newtons per coulomb, or the units, or volts per meter, either one. Newtons per coulomb is more intuitive. Alright, now I want to know the magnitude of the direction of the force on a 2 coulomb charge located at this position. So I can find the force is equal to Q times the electric field. So my force in vector notation is just 2 times the electric field, which is going to be negative 6I plus 16J. And that's in newtons. That's just twice the electric field, because my charge is 2 coulombs. Now, if I sketch this out, my x component is negative, my y component is positive, so this vector is going to be in this direction. I want to find that angle and find the magnitude. The magnitude of the force is from the Pythagorean theorem, 6 squared plus 16 squared, and that's equal to 17 newtons. And then to find the angle, the inverse tan of 16 over 6, which is 69 degrees. That's above the negative x-axis. You could also express it as what, 111 from the positive x. Just do 180 minus 69. So that's the answer. Generally, counted this as 12 points, this part, and this bottom part down here as about 8 points. when I was grading it. Many people got this right. Alright, consider these charges. They're at the vertices of a right triangle. The magnitude and direction of the force acting on particle 2. Alright, so I want to know just sketch in the force first. There are two positive particles. So it's going to look like that. That's my angle theta. Because these are two crossing lines, this is also my angle theta. Let's just go ahead and find the angle theta. Theta is the inverse tan of 3 over 4. That's opposite over adjacent. That's 37 degrees below the plus x-axis. Alright, and then I also need to find the magnitude of that force. That's from Coulomb's law. That's 9 times 10 to the 9th times Q1 times Q2. It's 1 times 10 to the minus 5 times 2 times 10 to the minus 4. So both in coulombs, divided by the distance squared. That's 5 meters squared. This distance is 5 meters. You can find it from the Pythagorean theorem. That is the square root of 3 squared plus 4 squared equals 5. R just, you know, it's 3, 4, 5 triangle. So, and then that works out to be 18 over 25. What you do in your calculator is 0.72 newtons. So that's the answer. It was 10 points, typically 5 points for each part. Consider this configuration of charges. Want to know the potential? To know the potential at the location of Q2, that is, what is the potential here? Now, I recognize that I have a plus 3 and a minus 3 here, so the potential of those two charges is going to cancel out. So for the first part, for part A, which I'll do it right up here, that potential is just going to be due to this charge, the minus 4 microcoulomb charge. So it's KQ over R, that is 9 times 10 to the 9th, times Q, which is 4 times 10 to the minus 6. Actually, this is a negative value, over my distance, which is 4. So that's negative 9,000 volts. So that's part A. And then what is the total work required to assemble the charges? You have 4 things you need to add up here. Let's first just imagine that we bring in particle 1. It requires 0 work. Particle 2 is Q2 times V1. That is 1 times 10 to the minus 6 coulombs. That's Q1, or excuse me, that's Q2, which is 1 microcoulomb, times K times 3 times 10 to the minus 6 coulombs over 3 meters. That's KQ over R, and that gives me 9 times 10 to the minus 3 joules. And work 3 is going to be Q3 times V1 and V2. So the potential due to particles 1 and particle 2, that's going to be Q3, which is negative 3 times 10 to the minus 6 coulombs, times K1 over R, which is 3 meters, plus K3 times 10 to the minus 6 over R, which is 6 meters. And that gives me negative 0.0225. Sorry. Joules. 0.0225 joules. And then finally work 4 is Q4 times the voltage due to particles 1, 2, and 3. But I've already determined that the voltage, the potential due to particles 1 and 3 cancel out. So I can just consider particle 4. Or excuse me, not particle 4, particle 2, because the voltage due to particle 3 and particle 1 at this position, they cancel out, so they just go away. So I'm just going to say negative 4 times 10 to the minus 6 times k times 1 times 10 to the minus 6. That is this charge right here, all over 4 meters. That is negative 9 times 10 to the minus 3. And then if I add up all of these, work 1 plus work 2 plus work 3 plus work 4, that's negative 0.0225 joules, because I see that this one cancels with this one. That's the final answer. Alright, one more question. Some of you got all the numbers right, and that was really easy to grade. But some of you might have gotten the equivalent capacitance wrong initially, and then that messed up all of your numbers as they went along. So I tried to track it through and sort of see the calculations that you made to give you partial credit. Even though all of your numbers were wrong, they that was caused by an initial error in finding the equivalent capacitance, and then it propagated through. So I tried to account for that as best I could, but it was kind of difficult to see some of your work. So first, let's take some things and combine them. I have these two capacitors I can combine. That's a 3 and a 6. They combine to give me a 2 microfarad capacitor. And similarly here I have a 2 and a 2. They combine to give me a 1 microfarad capacitor. So my circuit then can be simplified to look like this. I have 12. That's my 3 microfarad capacitor. And then I have 2 parallel branches. There's 12 volts. 3 microfarads for C1. This is 1. This is 2. This is 2. And this is 1. So each of those parallel branches simplify to a 3 microfarad capacitor. So my final circuit are just 3 microfarad capacitors. And the equivalent of that, 1 over 3 plus 1 over 3 plus 1 over 3 is equal to 1 microfarad. Alright, so my C equivalent is 1 microfarad. Now, I want to go through and figure out the voltages and what have you. Now, I know this is 12 volts, and it's split evenly across 3 capacitors. So this one's 3 microfarads. So they have equal voltages because they're all in series, and they have identical capacitors. Right, so that means that I have 4 volts here, 4 volts here, and 4 volts over here. So I can go and put in 4 volts for V1. Right? And then also, since I know that C1 is 3 microfarads, I can just say 4 times 3. So this is 12 microcoulombs. Now, I also know that if this one has 4 volts, then this capacitor, C3, also has 4 volts, because I have this parallel branch. It's going to have 4 volts across it because they're in parallel, and so C3 is also going to be 4 volts. Alright, in a similar argument, I can say that C5 also has 4 volts. Alright, I can fill in the charges here. C3 is 1 microfarad, so Q3 is 1 times 4. That's 4 microcoulombs. And similarly for V5, it's 4 times 2, which is C5, so this is 8 microcoulombs. Now, these two capacitors are identical, and they share 4 volts. So I'm going to get 2 volts here and 2 volts here, because I know that this capacitor has 4 volts, and it is made up of these 2 capacitors, so they each get 2 volts. 2 volts and 2 volts. Let's see, they're both 2 microfarads, so it's going to give me 4 microcoulombs and 4 microcoulombs. Now, that leaves me with C2 and C4. I know that collectively these guys share 4 volts. So I have 2 capacitors that share 4 volts. Let me just sketch that out down here. So here's C2 and here's C4. They share 4 volts between them. Alright, but it's not split evenly. So I need to find the charge on them. Now I know that the equivalent of them, of those 2 capacitors, is 2 microfarads. So that means that I have a charge of 8 microcoulombs on each of these. So I have 8 and 8. And then knowing that, I can go back and find the voltage. The voltage is what? Q over C. So it's 8 over 4. Or excuse me. Yeah, the voltage is Q over C. That is 8 over C2 is 3 microfarads, and C4 is 6 microfarads. So that's the voltages. C2 has 8/3 volts, and C4 has 8/6 or 4/3 volts. And notice that 8/3 plus 4/3 is 12/3, which is 4. So those are the answers. Generally, a number of you, your voltages were all wrong, but you calculated the charges correctly. So, you know, I still gave credit for those, even though you're sort of missing the bulk of the problem. But I counted each individual thing as just 1.5 points, which is actually giving a few points. So, anyway, not an easy question. You'll probably see it again on the final, though. And there's the multiple choice answers again. And that's the end.